In this video, I would like to experiment with character-by-character comparisons. So our next challenge is to put together a very simple algorithm to compare two strings, in fact, compare individual characters in them. So how do we actually compare the matching parts? We could try using indices of individual characters and compare each character with another character in two of these strings. Okay, so let's start with the demo program. I already have a file for it. It's an empty file. So we can start with the same approach we used in one of our previous videos discussing the possibility of detecting which string is shorter and which one is longer. So we use this very simple if statement as we did in that prior example, and if the two strings according to their variable names do not appear to be short and long, we will swap them. And you know the swap involves three steps. First, we take one of the strings. For example, we can take the short string and we can basically preserve it. Then we can override its value with another string that we have, just like this, right? And then finally, we use the temporary preserved string to override the second string. So this way we don't lose any information. And the outcome of it is, you can see that in this demo, I intentionally enter a longer string as a short one so that we always test the swap with this specific input or two input strings that we use for testing. Anyway, so let's print them both so that we can still see that they have been swapped properly, right? So the one which is longer and which is shorter, this is okay, just for the sake of testing. And then the approach for this comparison of strings would be that we need to search for each individual character. So I would like to try to use a longer string and say that as soon as we run out of characters in the longer string, the whole program should stop. Okay, so this is the basic idea. So we create an index variable. It's a number, right? So it's an integer that starts with 0 because the index of the first character in every string is a 0. And we can use this super simple loop to keep this index within the boundaries of our long string, right? So we begin to work with the long string and say its index should be less than the length of the long string, as long as its condition is true and the first index is 0, then we have existing character and the corresponding index, and this is our first loop. So then we do exactly the same with a shorter string. Okay, so we just say that we also can have index into the shorter string, and we can have the loop that keeps the shorter string index within the boundaries of the short string, right? So we have index short is less than the length of the short string, just like we did with the longer string. And then how do we try to match these characters? We just simply use this some sort of if statement. This again in Python, it needs to be aligned correctly with the respect of the indentation, right? So typical indentation is 4 spaces. This is your sort of like Python programming style to keep the correct indentation, which defines all the blocks that belong to the corresponding if statements, while statements, other constructs. So we say that if we use index to access a character inside the short string, right? It's just short, like notice the consistency that I use with naming my variables, right? So everywhere I refer to the short string, I use this as a suffix in naming my variables, and correspondingly with the longer one. So this square bracket syntax, the index axis returns character of a short string, and this one returns the character of a long string. And if this condition is true, then we have a matching character, right? So we can add a comment here. Now notice that this comment begins the block that belongs to this if statement, and we have a matching character. So first thing I would like to do with it is just print it, right? I just want to display it. Okay, simply display the matching character, right? So here I use short, index, short, but I could be using long, index, long. They're both the same. I'm just printing the character. And again, the ending of this print call output, I'd like to not to decorate with any kind of spacing or new lines, just keep it an empty string. Okay, and if you think about it, for instance, this using these two strings as an example, if, for example, we found a matching character A, okay, so somehow we match this. So of course, the indices will be incremented, but we have two loops that belong to each other. So in this case, the longer one, right, the longer index needs to be incremented here to prepare for matching the next. Let me just adjust my font size. Okay, so here I will I will increment it, index long equals index long plus 1 to prepare long index for next adjacent match. And look that this happens only if we have a matching character. Under no conditions, basically without any conditions, to be able to make progress through our loops, I add this statement here that essentially, again, watch for my indentation. This statement increments the short index variable so that, you know, we consistently process all characters inside the short string, incrementing the index. But if we have a match, if we already matched A to A, then we need to be able to, so this statement will increment the index. So if it's a shorter string here, it'll move to the next character, the index will move to the next character, but we also need to increment the index here so that we'll be comparing the next adjacent match, right? So I have this a comment here that says the next adjacent character match. This is why we have this statement over here. Okay, so that's part of our algorithm. And I am just printing this and incrementing both indices. And as soon as we completed the match for like doing the checks against the first character, here, and eventually we terminate this loop. We get out of this loop, but we still inside the first loop here, so we can then increment the long index as well, right? So let's just add some empty lines here to kind of like highlight the second loop, the first loop, and this is the work. And it's just a simple, I think the simple ending of it is just like we had before. I can just print an empty line and pause the program before it exits. Okay, so I'm going to save this code and run it. Right, so this is my next example. Let's clear screen, and I'll just drag and drop it here so that we can try subsequent attempts to test this. Again, I don't need the full path here, although I could use it. Hit enter, and oh, I've got an index error. This is pretty clear that if you look at the code, why at all any kind of index error may be happening in our code. That's a great example to highlight this type of error that is very, very typical when you just, starting to program this. The thing is that we have two conditions. One guards the long string index within the boundaries of the long string. Another condition guarantees that the short index stays within the allowable boundaries of the short string. However, in order to be able to compare adjacent characters, we had to increment the long index inside, inside the block of this if statement. Otherwise, we would not be able to would be comparing the same character to bunch of characters down here, which just doesn't make the algorithm work. So what we need to do is a very, very simple check, right? So the idea is that if this happens on this line, so this clearly happens inside the second loop. So before we attempt to do anything, I think just simply we add a little bit more logic here. We say that in case if this long index already ended up being, as a result of this increment, outside of the boundaries of the long string, and it's just basically the index that we use to access the long string, right? We break. And this is the statement. Again, if you read the book, it tells Python that this break statement will simply stop this loop as soon as the break statement is reached, and we get out of this loop, and at the result of this break, this whole thing, this loop, will stop, and we move on to the next line, which will allow us to continue with the rest of the characters. Okay, and yeah, so let's give it another try. I'm going to save this. I think that should be the fix. I'll just rerun this, and here we have this kind of rough matches to show us what characters and in fact subsequent characters, adjacent characters, have been matched here in between the two of these strings. So we have really kind of short little fragments, but they're also quite recognizable fragments, such as all and play and jack, with some extra parts here, but still we have these recognizable parts. So this is not yet finished program. It looks a little bit rough, right? But it definitely is a step in the right direction. We attempted something initially to implement this idea to compare individual characters and be able to keep looking at the adjacent characters and be able to see if we can find matching substrings. So the highlights of this sample, which I think is complete, and I'm just going to save it the way we have it right now. So the highlights here, that first of all, we have nested loops. I intentionally avoided this term until the end of this video to say it as a highlight, that we have these nested loops. When one loop appears inside the body of another loop, right? It belongs to another loop, right? This one we call this is a nested loop, the loop which is nested inside the original loop that we had at the top. To be able to do the coding walkthrough, there's another term which I also intentionally postponed till the end of this video, which is the outer loop and the inner loop, right? So it's sort of like let's just let's add a little bit of commenting here just for our terminology. Outer loop, right? Outer loop, and then right here we have an inner loop. Okay, so this is very common terminology, not necessarily in Python, but in all other programming languages that allow us to write the loops. And yet another highlight here, which is very clearly in play, is that we have loop controlling variables. When we have a variable like this index long, which participate in this condition, which of course, its intention is to eventually terminate the loop, right? And that we consistently increment or decrement this, this variable, which participates here in this condition. We call it a loop controlling variable. Okay, so it's another recognizable in across multiple programming languages term that we have loops. Loops have conditions. Conditions have variables that participate in our comparisons using comparison operators, and of course specific variables control when the loop terminates. Naturally, the index runs out of allowable range. We want to stop the loop, so we refer to it as a loop controlling variable. Similarly, inner loop also has its own loop controlling variable, which is index short. So these two variables are examples of loop controlling variables. Of course, the break statement that we mentioned is another highlight of this demo. It helps to handle an exception to, in our case, our indices could be out of range as a result of our index manipulation. And we say, okay, then we may have this special case, an exception to the rest of these conditions that we try to rely on. And so for this, we can use the break statement that when we need to, we terminate a specific loop. And this break statement belongs to the inner loop. So it gets us out of the inner loop, but not out of the outer loop. So that after this break, this statement executes, which belongs to the outer loop. Okay, so that's definitely highlight of this little sample. And well, I guess we could try something like this just for the sake of demonstrating, more complex conditions, I guess. Over here, I could add another another part of this character comparison. For instance, I could say when one of the characters is not space, right? So this is like I just added this part. Okay, so it's a very similar condition. So I say let's use matching characters, but let's exclude spaces from comparisons. Yeah, I could do something like that, right? And so I say that let's make sure that this character here is not a space character. I use single quotes, and I use just space inside the single quotes to compare with the space. And as long as our character that just matched is not a space, then do the work that we do, right? So with this, let's save this and run again. Okay, so this time you see the spaces were excluded here from the output. So this just demonstrates that okay, if the spaces are excluded, then we don't have spaces included in adjacent characters, which is the case in our example here. So my battery is running low. I need to plug in my adapter. So I'm going to stop this video and we will continue in our next video to discuss our prototyping.